Recording.
All right. Great. Good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap. I love this topic. I think this is going to be a great presentation. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is, and we are taking questions from the audience, that's what it is. So if at any time during today's presentation you have a question for our speaker, please don't wait. Don't hesitate, just use the question and answer tab right there on your interface and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. We also have a very interactive chat feature, so I do encourage everybody to send us your comments, your questions, your suggestions, whatever you like. Go ahead, just use that public chat feature and send it on in, and we'll keep an eye on it throughout the webinar. And we do have a polling question, which we'll be pushing out at the beginning of the question and answer period, so please be on the lookout for that. And then finally, at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards, so please stick around. Hopefully you will be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Deliver Your Kubernetes Applications as a Service. Our speaker today is Devdatta Kulkarni, who is the founder of CloudARK. Devdatta, thank you so much for joining me today. It's a pleasure to see you.
Thanks, Charlene. And hey, everyone. As Charlene said, wherever you are, good morning, good afternoon, good evening. I'm Devdatta Kulkarni, and I'm so glad that you have decided to come to this webinar, delivering your Kubernetes applications as a service. Before I get started, I just wanted to introduce myself and our company. So I'm the founder of CloudARK. We are a startup based in Austin, Texas. We've been serving global customers on their cloud-native SaaS journey. And some of those experiences I'll be sharing it with all of you today. The main thing that we specialize in is Kubernetes extensibility. So Kubernetes as a platform really started taking off around 5 years back. And Kubernetes extensibility is a more recent topic which has really enabled the base Kubernetes platform to be extended in various ways to run various different kinds of applications. And in today's talk, we will see how Kubernetes can be leveraged to deliver applications in a service form. We have been working with industries, enterprises across industries. Some of our notable clients have been Verizon, DataStax, PayPal, Wisdom Labs, and so on. Before I get into today's agenda and what we are going to discuss, I'd like to say thanks to the Red Hat Marketplace team who is sponsoring this webinar. Towards the end of the talk, I'll be sharing with you our product KubePlus SaaS Manager, which is now available on Red Hat Marketplace. So this webinar is part of that series. So here is the agenda that I have for us today. I won't probably need an entire hour, so we will have ample time for question and answers. As Charlene said, please write out your questions in the question and answer section of our platform. You can also use the chat window to ask any questions or just comments, and once the webinar towards the end, we will go through them and answer your questions. So what are we going to learn today? I'll start with describing a typical ISV's cloud native journey. Many of the ISVs today are looking at Kubernetes and containers, and they are on that path. Some of them are really early in the stage. Some of them have started adopting Kubernetes, and then there are others who are well into their Kubernetes world, and they are looking into how to leverage Kubernetes even more to either gain more market share or make it simple for their consumers to use their applications. So we'll start with that. Then briefly we will look at what is a Kubernetes application. This is just to level set to understand what it involves when we talk about a Kubernetes application. Then we will dive into delivering any enterprise software as a service, and typically how that happens on Kubernetes, or what needs to happen for a SaaS delivery of an application on Kubernetes. We'll look at the stakeholders involved and what are the common patterns that we have seen in our engagements. And then towards the end, I'll present to you KubePlus SaaS Manager, which solves the problems which are typically encountered when delivering applications as a service on Kubernetes. I have a demo of WordPress as a service, which through the screenshots, we will be able to see how KubePlus SaaS Manager makes it possible. So that's the agenda. So to begin with, today, many of the ISVs and application vendors, they are looking at Kubernetes and thinking about where should they go with their software. They do want to leverage containerization and make sure that their software is built in a way that it can be distributed to different clouds or on clients' premises or even on edge locations. So the typical journey of an enterprise software, at least that's how we have seen it, goes through 3 phases. You start with containerization. You build your Docker containers for your application. Then once you have built the containers, then the next phase is to package your application for Kubernetes. And why Kubernetes? Because that is now becoming the standard for running containerized workloads. So typically, that's the next step that an enterprise is going to take. And then the third step is to actually figure out how now you can distribute this Kubernetes application that you have packaged in hybrid multi-cloud setups, which are the main point there being that Kubernetes being the common infrastructure layer. Once you have packaged your application for Kubernetes, it can run on different public clouds. It can run on premises like on OpenShift kind of setups, and also on edge clusters. So once an ISV figures out that I need to go through these 3 steps, and once they have done the containerization, the next step is packaging the application for Kubernetes. And when it comes to packaging an application for Kubernetes, what it really means is you need to define your application in terms of Kubernetes abstractions. And Kubernetes as the infrastructure platform provides us many abstractions. There are things like deployment and service and pod and custom resources. I won't be going into the details of these, but if you are new to Kubernetes, you can learn about these abstractions on kubernetes.io. But probably you already know about these abstractions. What these abstractions do is they help us model our application in terms of Kubernetes' language. So for example, if your application needs a front-end load balancer, then there is an abstraction called service, which will give us that. And just the actual container that we have created, the abstraction that wraps that container is the pod abstraction, and so on. So all of these abstractions are represented as YAML files. And when you decide to package your application for Kubernetes, you can just work with plain YAML files. That's like the most standard and the first step that you will start out with. But then eventually you will templatize those YAML files and you will create a Helm chart out of that. So Helm is a very popular packaging mechanism for Kubernetes applications. And then if, let's say, your application needs to be provided with some extra configurability, which is not possible through these generic abstractions that Kubernetes provides, then what you will end up writing is a Kubernetes operator for your application. Now, Kubernetes operators is a big topic, and today's talk, we won't be talking about operators in this webinar, but just a quick two-line summary of what an operator does is an operator for an application is meant to perform application-specific configurations which are otherwise not possible to do or will require a lot of customization. The operator is a software that will do all of that in a Kubernetes native manner. So that is yet another way of packaging a Kubernetes application. So once you decide on what type of packaging strategy you want to have, then as an ISV, your next goal is now, how do I go and run this application in these different setups, be it different public clouds or on-prem or on the edge, basically achieve the hybrid multi-cloud delivery of your Kubernetes application. So that's your next goal. Now, moving on to the actual challenges of delivering an enterprise software in a service form, and then how those challenges arise in the Kubernetes context. So if you look at any SaaS-based delivery, the three things that are critical from the perspective of SaaS model are day two operations, multi-tenancy, and usage-based billing. So let me spend a couple of minutes talking about each of these. So when you think about delivering anything as a service, so what we are saying is the consumer of the software does not want to be burdened with installing and managing the software, but the consumer wants to consume that software in the service form, right? So that's our software as a service delivery. The crux of the SaaS model is that the consumer wants to consume that application in a service form. So now, on the flip side, the provider of the application wants to be able to manage that application on the behalf of the consumer. So the consumer will just consume it in a self-service manner, but the provider wants to be able to, for example, troubleshoot their own software, or they want to scale or upgrade their software. So these are all day two operations which the provider of the software needs to perform, and the consumer does not need to be burdened with those operations. So that's one of the pillars of SaaS, where the software provider wants to be able to come in and perform the day two operations. Okay, so that's one of the aspects of SaaS. Another aspect is how to manage the multi-tenancy of the software. And by multi-tenancy, what we mean here is there will be consumers who want to use your software, and let's say those consumers are part of the same organization, but they want a separate instance of your software. So you as a service provider or the software provider, you want to be able to easily create or easily enable creating multiple instances of your software. So what we call this as multi-instance multi-tenancy, where a complete instance of the software is created for serving a particular consumer, and so each consumer will get a complete instance on its own. And I have an example later which will through which we can talk about this multi-tenancy aspect a bit more. And then the third aspect which a provider of the software is interested in is to be able to track resource consumption of each of these instances of their software. The reason being that as part of the SaaS model, usage-based billing is very critical, because as providers, they want to not just have a flat chargeback mechanism or charging model for their software, but instead they want to really be fine-grained in how they price and charge their software when they deliver it as a service to the consumers. So usage-based pricing also becomes a key part of the equation. So when it comes to Kubernetes, and thinking about how do these three pillars of SaaS translate into Kubernetes world, or what are the challenges when it comes to Kubernetes world, we have to start out with the first step that we saw in the previous slide, is where you, as a software provider, you have started out and built a Kubernetes application, which is, let's say, the Helm chart. Okay, and now from the Helm chart, you want to go to the point where that Helm chart can be delivered as a service. And when we say deliver the application as a service, we want to be able to have a handle on all those three points that we talked about: day two operations, multi-tenancy, and usage-based billing. So once we sort of ground ourselves with these three challenges, the next step, when we drill down more into the Kubernetes world, we have to ask this question: well, who are the stakeholders when it comes to delivering a SaaS on Kubernetes? So there are these three stakeholders. There is the application provider, application or software provider, who is whose software, who is the one who has essentially created the Helm chart, and they want to deliver that as a service to their consumers. And so the application providers are more interested in things like, how do I manage the day two operations? How do I get usage-based billing for my application, and so on. The second stakeholder is, of course, the application consumer. Now, the application consumers, their main concern is, I want to be able to, if it is being delivered as a service, then the main thing for consumer is that they want to be able to self-service provision the application. So they don't want to be like, filing tickets to get an application instance, but they want API-driven way of instantiating the software. And then because this is the software is going to run on the Kubernetes cluster, Kubernetes cluster admin also becomes a key stakeholder. And the cluster admin, the main concerns that the cluster admin has is, how do I ensure that the provider who is going to deliver their software as a service on my cluster, how do I ensure that that provider has just enough access and not like a cluster admin privileges on the cluster? And also for same thing for consumer, if the consumer needs to be able to use some APIs to instantiate that software, then as a cluster admin, I want to restrict the permissions for the consumer as well, only to that API. So that's one aspect. The other aspect as a cluster admin that I am interested in is, of course, how do I keep different application instances separate? And this goes back to the point of multi-tenancy, where the creating every instance of the application for as needed by the consumer, these are separate instances. And as a cluster admin, I want to make sure that there is clean separation between these instances. So once we now understand that these are the stakeholders and the pillars of SaaS and how they will translate in the Kubernetes world, we want to sort of take a step back and look at the common patterns that we have seen in real world when it comes to delivering Kubernetes applications as a service. So the two patterns are, as you see here on the slide, the first pattern that we have seen is that of a managed service. And what the managed service pattern essentially means is that the cluster, Kubernetes cluster ownership and management is done by the consumer organization. and the application provider is someone who is outside the organization. And to explain this a little bit, I'll give you an example of the wireless service provider and 5G application that they are building, and we were working with them. So the setup there was that the wireless service provider had all these edge clusters, and the 5G application actually came from a separate 5G application vendor. And what they provided to us, to this wireless service provider, was just an application Helm chart, and the cluster admin for these edge clusters and the consumers, they were part of the same team within that wireless service provider's organization. So the reason we call this as a managed service setup or pattern is because in this case, what happens is the application provider, he or she or that team is outside the consumer organization, and the consumer want the application to be managed by the provider. So that's why the pattern, we call it as the managed service. And then another pattern that we have seen is what we call as public SaaS, where it is the application provider and their organization who owns the Kubernetes cluster, and the application consumer is someone who is outside that organization. The example here would be there's we worked with a company who was building Moodle as a service. So Moodle is an e-learning platform, and what they wanted to do was build a Moodle SaaS where for their customers were all these schools, and for within a school, there will be, let's say, different courses that different teachers will be creating. And so for every course, they wanted to have a separate instance of the Moodle. And the company who was delivering this Moodle as a service, they were the cluster admins and they were the providers of this Moodle application. But the consumers were external entities like the schools who were signing up. And then the teachers within those schools, the Moodle instances were created for them. So based on who is managing the cluster and where does the application consumer and application provider sit, we see these two different patterns as far as delivering application as a service on Kubernetes. Now, a quick note here on multi-tenancy, and picking up this point from our couple of slides before, is when it comes to Kubernetes multi-tenancy, what we have seen is there are two ways you can support multi-tenancy in Kubernetes. One is you can have what is called as namespace-based multi-tenancy, where within a cluster, there are separate namespaces which you will create and use that to separate different application instances, or you will actually create separate clusters for different tenants. So there is no hard and fast rule of how this multi-tenancy should be there. It depends on every organization, or every situation is different. The most common pattern that we have seen is you would give a dedicated cluster for a particular organization and then use namespace level multi-tenancy for separating multiple application instances. And that's the example that I mean, in the Moodle as a service case, that's exactly how it was done, where every school got their own separate Kubernetes cluster, but for within that, they had namespace-based multi-tenancy where separate Moodle instances were created for every class within that school. So now is the time for me to talk about those were the problems that we saw, and now we will see how these problems are addressed through KubePlus SaaS Manager, which is our product. It's available on Red Hat Marketplace. and it's certified with OpenShift. It runs on other Kubernetes platforms as well. Through OpenShift, we got it. We went through the complete certification, and so it's available on the Red Hat Marketplace now. So what KubePlus SaaS Manager is, it is the software which enables solving for these two use cases, the managed service and the public SaaS. It consists of two components, and I'll briefly talk about both of them in next two slides. One of the components is an open source software that you install on your cluster, and then there is a control center which can be installed anywhere. As far as the managed service use case goes, what KubePlus SaaS Manager provides, or the key aspect that it provides, is it enables remote management of your service in customers' Kubernetes environment. Think of that 5G application example that I was talking about, where the application provider was someone who was not part of the organization, and the need there was that it should be possible for the 5G application provider to come in and debug or troubleshoot any issues that are happening with their application, but that application is now running on edge clusters of that wireless service provider. So that's where the remote management aspect comes into play, and KubePlus SaaS Manager has the right APIs and RBAC policies which makes this happen. And then on the public SaaS side, the key aspect is that there are applications are created in separate namespaces. So as you can see here, we have different tenant 1, tenant 2, tenant 3. So different app instances are created within the same cluster. And so KubePlus SaaS Manager supports namespace-based multi-tenancy. So the open source part of KubePlus is actually a project that enables delivering Helm chart as a service. It is available on GitHub, and you can check it out. We have the link right there. And by the way, you will be receiving this slide deck after the webinar. So you will have all these links that you can go and check out KubePlus on GitHub. So what KubePlus does, the open source part of KubePlus, what it does is it abstracts an application Helm chart under provider and consumer APIs. So the key idea that we have is that the application package, which is Helm chart, it needs to be wrapped under APIs, so that the APIs provide us the control point for like defining and enforcing policies, for tracking usage, and also for the consumers to do their self-service provisioning of the application. So the provider API is something that KubePlus provides, and I'll walk through an example on the next slide. Through that provider API, the provider will register their Helm chart into the cluster, and then as part of the registration step, the consumer API will get created. And then once that consumer API is created, the consumers use that consumer API to instantiate applications as and when they need it. The control center, KubePlus Control Center, is actually a set of tools that help you manage as a provider. You can use this to manage your SaaS across different organizations. It comes with embedded Prometheus, so you will be able to track how your different organizations, applications on different organizations clusters are behaving. You'll be able to, there is a control center shell through which you can actually log into these clusters and then troubleshoot and basically perform day-to operations. The permissions that you as the provider are going to get on these clusters are very restricted to be able to only perform actions on your application resources and nothing more. So KubePlus ensures that you don't get like wide permissions. And this is important from cluster admin's point of view, because they don't want to open up their clusters to the providers with a wider range of permissions. So KubePlus Control Center has all these features baked in. So here is a demo scenario which will help ground all of this discussion. So suppose you are a WordPress service provider and you want to deliver WordPress in a service form to your consumers. But by service in a service form, by that what I mean is your consumers should be able to create WordPress instances in a self-service manner. So through some APIs, your consumer should be able to create WordPress instances. Then you, as the provider, you should be able to track the metrics like how much CPU, memory, storage, network ingress, egress for each of these WordPress instances. And then as a cluster admin, you want to make sure that different instances are isolated from one another. So that's our ultimate goal. So the first step will be, as a provider, you will start out with a WordPress Helm chart. So let's say we start out with a very simple Helm chart where there is a WordPress pod, WordPress service, and a MySQL pod and a MySQL service. So you'll create this WordPress Helm chart. And then on the cluster admin side, the main thing that the cluster admin has to do is the cluster admin has to install the KubePlus open source software into their cluster. So that's all the cluster admin has to do to begin with. Now, once cluster admin does that, what the provider then needs to do is provider will define the WordPress service. And this is where it's the step where it registers a consumer API into the cluster. So here's how it looks like. We have in KubePlus, there is a provider API by the name resource composition that we have defined, using which the provider creates a new consumer API. So here I have given the name of the consumer API as WordPress service, and the input that needs to be given to this consumer API is the URL of a Helm chart. Okay, and then there are also policies that one can define when you register this API. So what this step does is the provider will create this resource composition YAML. As part of that resource composition definition, it will define some consumer API. It can be any name, doesn't matter, as long as it's under this particular group and version. The kind name can be anything. And that kind WordPress service is the new kind which will get registered in the cluster. And what this kind WordPress service is going to do is, whenever the consumer will take this or create an instance of WordPress service, this particular Helm chart which has been registered, the Helm chart will get deployed in the cluster. Okay, so a new Helm release will get created whenever the consumer instantiates or creates an instance of WordPress service. And then where do these policies come into play? So the policies are going to be applied. KubePlus will apply these policies for every instantiation of this Helm chart. So whenever consumer creates a WordPress service instance, behind the scene, KubePlus is going to do two things. It's going to deploy this Helm chart, and then as part of deployment, it is going to apply these policies. So the policies that we support are things like every, let's say, pod within that Helm chart, we want to ensure that it gets some specified CPU and memory. So you can specify that. You can also specify things like, okay, this particular Helm chart needs to be or Helm release need to run on a particular worker node. So you can specify node selector policies as well. So once as a provider you register this or create this WordPress service, the next step is again as a provider you want to start your control center, which can be installed anywhere, and what it provides you is a set of kubectl plugins to manage your service instances. Okay, so you start out with registering the service, so give the name, some name to the service, and then take that YAML file and register that. Then you register your organization. So this step essentially will require you to give input as the kubeconfig file, which the cluster admin needs to share with you. So this is basically the kubeconfig file, which restricts your permissions to only the things that you should be doing and nothing else. So KubePlus will generate this kubeconfig file. Cluster admin, when they install KubePlus, they can retrieve this kubeconfig and share that with the provider. Then provider registers that organization, which is essentially the cluster, registers the service, and then adds that service into the organization. So this step will make this particular the new CRD that we have added, which was the WordPress service, that will get created as part of step 3. That will the new kind will get registered in the cluster. And then the last step is as the provider, you can then start monitoring the organization for this particular service. And as part of monitoring, what you as provider you are going to get is a Prometheus Console, which is per service there is a separate console that you will get in which you can track consumption metrics. So here is the screenshot of the Prometheus Console for this WordPress service. It's a console which is very specific to a service. So let's say if you as a provider have 2 different applications and you want to, let's say a particular consumer organization wants both of those applications, and they want you to manage, provide managed service for both of them, then you will be able to create that using KubePlus SaaS Manager, and you will get separate consoles for each of these. Now, as far as the actual metrics go, we track CPU, memory, storage, network ingress and egress, and these are basically aggregated metrics for all the pods that are part of that particular service. So when we say all the pods in a, let's say, WordPress service, what it comes down to is within a Helm chart, there can be definition of Kubernetes resources like deployments. There can be custom resources which are managed by some third-party operator, and they might be creating different pods. So what KubePlus is able to do is figure out all the pods that are part of a Helm release, and then aggregate these metrics for all those pods. Then the actual metrics that are collected, they are backed by the Prometheus's time series database. So you will be able to drill down on a particular metrics and then see the historically how that metrics has changed, which is very critical from provider's point of view, because that is what is going to give them ability to define usage-based billing. These metrics come in handy for that reason. And finally, you will be able to see here that the screenshot is showing 2 organizations. So as a provider, you will be able to see all the organizations in which your service is running. So this is like a unified view that contains all the organizations, and let's say if there are multiple instances of the application within each organization, then those will show up here as well. So basically, this is your, as a provider, this is your single point of view to understand how your service is behaving on different clusters, be it your own clusters. If you are in a public SaaS setup, then the cluster will be your own teams, your own organization's cluster. Or if it is in a managed service setup, then the clusters will belong to the consumer organization. So you will be able to see all of this. Finally, let's talk about the consumer side, because ultimately the consumer are still a big part of the equation, where consumers want to provision WordPress service instances through in a self-service manner. So what we provide in KubePlus, this is part of the open source KubePlus, is a consumer portal which runs on the cluster itself. So different clusters, wherever KubePlus is running and wherever the service that you have created is registered, you will get this portal that you can share, or the cluster admin can share access to it with the consumer. So this is a very service specific UI where the main parts are the actual creation of the service will require the consumer to enter some data in, and this is we have a form-based input to take the values that are relevant for the underlying service Helm chart. So remember that when we registered the WordPress service, there was a Helm chart for WordPress that was registered. So in order to instantiate that Helm chart, the consumer will have to provide some inputs, and this is how you will be able to give them the inputs. And once the application is deployed, they will be able to access the application, they'll be able to look at the application metrics, and also they'll be able to look at application logs. Now, let's say the consumers are not interested in using the UI, and or they want to automate this part of creating the application instances. Think about a setup where there is a CI/CD workflow, and based on and this is more relevant for probably the public SaaS scenario, where there is you have a web portal where a new customer comes in and they sign up, and then as part of their sign up, you want to behind the scene create a Moodle instance or a WordPress instance. So in that kind of setup, you want to be able to automate the creation of these instances, service instances, and you can do that by instantiating them through consumer API. So the consumer API is going to be essentially the new kind that we have defined, the WordPress service, and whatever the data that needs to be passed in, those are going to be the spec attributes from the spec attributes are values.attributes in values.yaml that belong to the registered Helm chart. So if you want to automate that, then there is the consumer API that you can use. But together, from the consumer side and the provider side, this is how you will be able to get the as a service experience, where you start with the Helm chart, and then they could convert that Helm chart into a service, and then KubePlus is able to apply some policies on that Helm chart. Is every instance is created in a separate namespace, and then through the KubePlus SaaS Manager and the control center, the provider is able to manage the application and perform day-to-day operations. KubePlus SaaS Manager subscription is available through Red Hat Marketplace. As I said at the beginning, it's KubePlus SaaS Manager will also run on any other Kubernetes distribution. And currently, apart from Red Hat OpenShift, we have validated it with GKE and EKS. And as part of subscription, what you get is solution engineering and support for the control center, and also our open source software. Beyond the KubePlus SaaS Manager, you can also engage with us in your SaaS journey. We can become your SaaS partners, where typically we start out with the Kubernetes extensibility training, where we cover things like what are Kubernetes operators, how to write them, how to write Kubernetes kubectl plugins, what it's involved in the access control for Kubernetes, and then generally like all relevant projects that you might need from the CNCF landscape. We will cover those. We will help you with packaging your application for Kubernetes. This involves actually the Helm chart creation, and we are also able to write operators for you. We will work together with your team to do the operator development. We have developed the operator maturity model, which is available on GitHub, which came about through our experience of working with enterprises where they were needing more than one operators in their setup. So the operator maturity model identifies the guidelines when it comes to multi-operator setups. And then lastly, you can then get the KubePlus SaaS Manager subscription, where you will get this control center with integrated Prometheus, and it's just a cookie cutter way you can create your SaaS. So just to summarize, many application providers we are seeing today, ISVs, are looking at Kubernetes as a way in two different ways. They are looking at it to standardize the deployment of their applications on different environments, be it different public clouds or consumers Kubernetes environments on-premise, on the edge, and so on. And they are also looking at Kubernetes and the way they deploy their application on it as a way to gain additional market share. Because now, once they package their application for Kubernetes, and if they can deliver it as a service, then it suddenly opens up there are many consumers that they'll be able to serve by just removing that burden of managing their application for them. So we are seeing this a whole lot when working with different enterprises. And so KubePlus SaaS Manager will help you. If you are in that boat, then I encourage you to give KubePlus SaaS Manager a look into. It's a turnkey solution which solves for the key aspects of SaaS, multi-tenancy, access control, day-to operations, usage-based billing, and so on. So you will be able to quickly get your SaaS up and deployed in any Kubernetes environment. We have a link on here which you can check out, where you can actually schedule a demo to see how KubePlus can work with your Kubernetes application. So encourage everyone to check it out. And yeah, that's all I have. Let me pause, and now we can go into question and answers.
Yeah.
Yeah, Charlene?
Yeah, great. So, wow, what a great presentation. I did mention at the top of the hour that we do have a polling question before we get into the question and answer period. So I'm going to go ahead and push that out now. You guys can go ahead and make your choice. The question is, which of the following options best describe your role as it relates to delivering a Kubernetes application as a service? You can choose from, I am part of an ISV that is looking to deliver our software as a managed service on our customer's Kubernetes environment. I am part of an ISV that is looking to build a public SaaS on Kubernetes for our software. I am a member of an enterprise DevOps team looking to deliver a managed service for a software to our internal stakeholders. Or I am a Kubernetes enthusiast trying to learn more about Kubernetes use cases. So you can go ahead and make your choice, and we'll leave this poll open for the entirety of the question and the answer period. And with that in mind, if you do have a question for DevData and you haven't put it in yet, please feel free to do that. We still have a couple minutes for question and answer. So let's go ahead and dive into what we've got question-wise. Here's a great one from Alexander, who, it's a couple of different questions actually. How often do you update Kubernetes components? We'll start with that one.
Oh, that's a great question, Alexander. So if you are referring to the cluster itself and the components that are part of the Kubernetes cluster, then we work with, as a provider, our view is, as someone who is going to help the provider, our view is that it will depend on the enterprise and how the cluster administrator who is managing the Kubernetes cluster. The software provider needs to make sure that they are closely in sync with the cluster administrators when it comes to underlying Kubernetes APIs. So for example, in recent release of Kubernetes, all those beta APIs are going to get deprecated. And so as a software provider, if your Helm chart is still using, let's say, those old APIs, and if your consumer's Kubernetes cluster is not going to have those APIs, then things will be problematic. So we do not have any specific suggestions for providers or the cluster admins, but as long as they are keeping up with the cadence of how the Kubernetes gets released, they are making sure that their clusters are up to date, I think that should be okay.
Okay, great. His second question is, will I get access to the Kubernetes cluster, the kubeconfig file with my certificates, namespaces, etc., in case I need to change something in my Kubernetes objects, like replicas for deployment? If not, who can do it and how quickly?
No, so actually you, as a software provider, you will get access to that. What KubePlus will do is the kubeconfig file, which will be generated, that is scoped to the new API that you will define. So as a provider, in the example that we saw, WordPress service is the new API that we defined, right? So what, as part of the service registration, KubePlus will generate these kubeconfig files, which will be scoped to all the resources that are part of that Helm chart, and which are also scoped to the namespace in which a particular instance will get created. So if you as a provider want to come in later and do day 2 operations of, let's say, changing the replica count, the kubeconfig file will allow you that capability. What it will prevent is you won't be able to change, let's say, something in the kube system namespace, or you won't be able to suddenly change number of, let's say there are some operators which are running on that cluster. So you won't be able to change anything there. The operator pod, you won't be able to mess around with that. So the kubeconfig files are more from the cluster admin's point of view. They act as the restricted set of permissions that the cluster admin is able to give out to the provider, and similarly to the consumer, there are even more restricted set of permissions that are granted to the consumer.
All right, great. More questions from Alexander. Do you use bare metal or VMs for Kubernetes clusters?
Actually, we do not, again, it doesn't matter to KubePlus SaaS Manager. It is going to depend on whatever the Kubernetes cluster choice that the organization is making, and KubePlus SaaS Manager will work, should work on any Kubernetes distribution. So yeah, as CloudARK and as KubePlus SaaS Manager as software, we do not really mandate any particular Kubernetes, any way of creating Kubernetes cluster. All
right, and then last Alexander question.
Questions, Alexander.
Right. Do I need to provide you with my own YAML files, or do you use your own in the case of deploying general applications like WordPress, DB, etc.?
Oh, that's a great question. So if you have YAML files, then we can work with those. Or let's say if you are not even there with defining YAML files, let's say if you just have your application in a containerized Docker container form, then we can work with you to define the YAML files. What we do need is the Helm chart. So Helm chart is the starting point for doing all of this. And also right now, Helm chart is the format that we have decided to support through KubePlus SaaS Manager. If in the future there might be other formats that we might support, but yeah, creation of Helm chart is something that we can work with you to do that.
All right, great. Just a final call for any other questions that you have. Please go ahead and use your question and answer tab and get them on in, or you can put them in the chat. We'll move them over for you, no big deal. Here's a question for you. Can KubePlus SaaS Manager work with custom resources coming from other operators that may be installed in the cluster?
Yes, absolutely. So that's a great question as well. There might be operators, other operators which are managing their own softwares on the cluster, and let's say as part of your Helm chart, you define certain custom resources, those which belong to those operators. Then KubePlus SaaS Manager will be able to figure out what pods are created as part of those, and then as part of building those metrics, it will be able to figure those relationships.
Excellent, excellent. Okay, let's see. Got one, an additional one here. Where does Prometheus run? Is it part of both KubePlus Control Center and Consumer Portal?
Yeah, so another great question. Prometheus actually runs only on the KubePlus Control Center. It is part of the tools that we provide to the software provider. And so it is not going to run on the Kubernetes cluster, but only on wherever you install the Control Center. And Control Center can be run anywhere. It can run on a VM. It can itself run on a Kubernetes cluster, but yeah, I mean, we are not currently complicating that too much. It's a set of binaries that you can run on a VM. Okay,
great. And final question here is, are the slides going to be available after the webinar?
Yes, so I'll be sending these slides over to Charlene, and then Charlene, you know the best, like what will be the next steps as far as slides are concerned.
So I'll confer with my producer, Jared, but I believe what we might be able to do is maybe attach the slides to the follow-up email that goes out to the attendees.
Yeah.
So if that is incorrect, I apologize in advance for that, but to everybody who did ask whether the slides will be available, please know that you will get a copy of the slides. We'll make sure that you get them. So how we do that, you know, what vehicle, I'm not quite sure yet, but we will definitely make sure that you get it.
Awesome.
All right, great. Well, that is all the questions that we have. So I do want to thank everybody who did submit questions. And if for some reason we missed your question, I apologize for that. But please know that that the folks at CloudARK are going to be getting a copy of all the questions that came in, and I'm sure that they will be more than happy to follow up with you offline to get your question answered. Also, a quick reminder that today's event has been recorded. So if you missed any or all of the event, you will have the opportunity to watch it again. Following the webinar, as I said, we will be sending out an email that contains a link to access the webinar. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars and look in the on-demand section, and it should be right there waiting for you.
So,
okay. Go ahead.
One quick point on that, Charlene. So if you did not get an opportunity to ask the question right now, and let's say later you think of something, that's my email address. Feel free to just send me an email. I'll be really happy to answer your question. Once you get the slide deck, you will have that handy. But before that also, you can just note that down and shoot me an email.
All right, perfect. Thanks, Devdatta. Okay, real quick, before we close things out, do want to do that drawing for the 4 $25 Amazon gift cards. So without further ado, our first winner today is Linda G. Congratulations, Linda. Second winner today is William W. Congratulations, William. Third winner today is Lynn Z. Congratulations, Lynn. And our fourth and final winner today is Trisha P. Congratulations, Trisha. We'll be following up with all 4 of you offline by email to get your Amazon gift card over to you. So please check your inbox. And if you don't see it there, please check your spam folder. Devdatta, what a great presentation. Thank you so much. It's a great topic. It was a great presentation. I do appreciate your taking the time and walking us through it today. I appreciate it.
Thank you, Charlene, and thanks everyone for coming for the webinar. Look forward to getting connected with you.
Yes, and I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please
Thank you.